Relative geologic dating. Here are your learning goals. Determine the chronological order in which geologic events occurred. Understand the principles of superposition, original horizontality, cross-cutting relationships, inclusions, and fossil succession. Let's look at these pictures for a minute, and this will help you understand relative geologic dating. When you look at the pictures of these three people, you don't know their birthdays. You don't know their exact ages. But do you have any trouble putting them in order from the youngest to the oldest? Nobody does. It's obvious that this person is younger than this person, and this person is younger than that person. And we don't need to know their exact birthdays to be able to put them in order from youngest to oldest. That's the idea behind relative geologic dating. Okay? We're going to determine the age by sequence of events. Okay? We're going to determine the relative ages of geologic structures based on what happened first, what happened second, what happened third, and so on. And there's some simple rules that we're going to use to help us figure that out. And we're going to go over them one at a time. Okay? The first one we're going to talk about is superposition. And that's really pretty simple. If we have layers of rock that haven't been disturbed, the oldest rocks are going to be at the bottom and the youngest rocks are going to be at the top. Think about it this way. If you made a giant pile of something, the oldest stuff in your pile would be at the bottom, and the things you put on the pile last would be at the top. And that's basically the idea behind this. The oldest layers of rock are at the bottom, the youngest are at the top, if the rocks haven't been disturbed. Original horizontality just says that sedimentary layers form in horizontal layers. Remember that sedimentary rocks are generally formed with the help of water, and water maintains a horizontal level. So even if you have a depression like this, as the rocks fill in, they'll make horizontal layers. They don't tilt when they form. If you find rocks that are tilted like this, then something happened after they were formed. The rocks formed horizontally, this direction, and then something tilted them up this way. If you see layers of rock that are bent, well, they weren't formed that way. They were formed in horizontal straight layers this way, and then they got squished, basically, and that bent them. So if they're bent, that happened after they were formed. Another thing that we use is something called cross-cutting relationships. And what that means is that faults or igneous intrusions are younger than the rocks that they cut into. Look at this picture of the sidewalk. Which is older, the sidewalk or the crack? Well, obviously the sidewalk's older. The sidewalk had to be there before the crack could form in it. And that's the basic idea of cross-cutting relationships. Rocks have to be there before you can have faults in them, or magma can intrude into them. So let's look at this picture. These layers of rock had to be present before this magma could squeeze into them. That's pretty simple, really. Okay? Let's look at another example. We know from the law of superposition that these rocks are older than these rocks are older than those rocks, these rocks are older than those rocks. So the youngest rocks in this pile are E, and the oldest rocks are B. Now we know that A is younger than B, C, or D because it cuts across them. Pretty simple. Here's another example. We have 4 layers of rocks that have been laid down horizontally. 4, 3, 2, and 1, and they would have been laid down in that order. This would be the oldest, then 3, then 2, then 1, right? Now, somewhere along the line, we had 2 igneous intrusions. We had 6 and we had 5. We know that 6 had to come after 4, 3, and 2 because 6 cuts across 4, 3, and 2. So they had to be in place before this igneous intrusion could occur. But look at 5. 5 cuts across 4, 3, 6, 2, and 1. So 5 has to be the youngest thing in this diagram. Everything else had to be there before 5 could cut across it. So if I asked you what's the oldest layer of rock, you'd say, oh, it's number 4. If I asked you what's the youngest, you'd be tempted to point to number 1 because it's at the top of the pile. But actually 5 is the youngest feature here because it cuts across all the other things. Now here's a fault. A fault is basically just a crack in rocks. You can see this fault cuts across all these layers of rock. So all these layers of rock had to be here before this fault could cut across them. So the youngest feature in this diagram is the fault. The oldest feature would be this layer of rock down here. Here's another. This is a really good example. I like this. So going by the law of superposition, we know that the A is older than B, B is older than C. We know from cross-cutting relationships that D has to be younger than C, B, and A because it cuts across all 3 of these. But the youngest thing is E, this crack, which cuts across A, B, C, and D. So E is the youngest, A is the oldest. And they would go in order: A, B, C, D, E. Alright, now let's examine this. Here we have 1, 2, 3, 4 layers of rock. We have an igneous dike, an igneous intrusion that cuts across them. And we also have a fault. Now, the thing I want to know is which is younger, the dike or the fault? We know the dike is younger than these layers of rock because it cuts across them. And we know the fault is younger than the dike because the fault cuts across the dike. So the youngest thing here is the fault. Another way we can determine age by sequence of events is by looking at inclusions. Inclusions are pieces of rock that get included in another rock. All right, so rocks that contain pieces of a pre-existing rock are younger than the pre-existing rock. So let's look at this picture. Here we have some sandstone and some granite. Now the question is, which came first? You would think the granite because it's at the bottom of the pile. But if you look carefully, there are pieces of the sandstone inside this granite. For that to happen, the sandstone had to be there first. Now let's look at this. This is just the opposite. Here we have sandstone, here we have granite. Now the sandstone contains pieces of the granite. So the granite had to be here first. So this rock contains inclusions of the older rock. This rock contains inclusions of the older rock. And the last thing we're going to talk about is fossil succession. Fossils occur in a definite order in the geologic record. If we look, trilobites were really common a very long time ago, but then they disappeared. And we don't find any trilobites after this point in the geologic record. From here to here, we find ammonites, which are basically a giant snail. So if you find ammonites in a rock, you know that it has to be younger than a rock that contains a trilobite. Another way we can use fossils is what's called correlation. Suppose you're examining a cliff and you notice these layers of rock containing these different fossils, and then you go across the valley and you see some more rocks, and you notice that these rocks contain these types of fossils. You know that this type of rock here is the same age as this rock because they contain the same fossils. So this rock would be essentially the same age as this rock, and this rock would be essentially the same age as that rock. Even though they're not the same types of rocks, they contain the same fossils, and we know those fossils only lived, the animals that made the fossils only lived for a certain length of time, so we know those rocks are the same age.